Yeah, thank you very much. Uh, yeah, is my screen visible?
Yes, sir.
Okay, thank you very much. So, uh, my topic of discussion today will be on recommender systems. This would be a very basic lecture, mostly focusing on the introduction of these recommender systems. Then, like we'll be discussing about the sources of information, basically the sources of information, like from where we can take the data for recommending, and various architectures of this recommender system, various types of recommender systems, and the evaluation process. So this will be a very very basic lecture, but quite informative for new people, for the people who have not yet known this about the recommender systems. Uh, so first of all, what is a recommender systems? We have a database here. Okay, assume that we have a database and a recommender system is created, and then it can recommend a few things. Okay, recommend some set of items. So when a user comes, okay, when a user comes, now from this database, using these recommender systems, okay, or set of recommendation algorithms, it need to recommend some set of items to this particular user. Definitely, we have known in our daily day-to-day life, we have been users of social media, right? You take it Facebook, or maybe like you take it of anything like YouTube, or some uh, this Amazon Prime or Netflix, or as such AHA or any other Disney Hotstar. All these type of channels are there, and these channels basically they deploy these recommendation engines. Okay, recommendation engines. And what is these recommendation engines? So these recommendation engines are built using some intelligent systems, or and it can be you can use it either a generic or a specific, or a combination of generic and specific machine learning techniques. So basically, ultimately, in these recommender systems, what is used is this machine learning techniques only, ultimately, or use it a deep learning architecture. Okay, to be more specific, to the latest engines. But conventionally, in the initial recommender systems use very very small simple machine learning techniques only. It used based on the similarity function that is that it uses. Okay, for each machine learning algorithm. Now, some examples, if you see some examples of these recommender systems are in the movie domain, as we have seen, like Netflix, Movie Lens, Film Affinity, or again, we have also gone through seeing in the movie domains like this Amazon Prime, AHA, Disney Hotstar, or so many channels are there like that. Or so, in the movie domain, so many vendors are there who can produce you a set of movies, okay, or all set of movies, and everything. Many of them are popular, right? Also, if you go through, you can understand that even in Netflix, Film Affinity, or Movie Lens, and all these are popular. Uh, uh, Popularly, they produce you various types of movies, uh, and this in you can understand that, or you can just go through, or if you have seen one movie, they recommend you automatically some movies based on your watching of the movie, what type of movies that you watch, or and that too based on timings also, during what time what type of movies that you watch. Maybe probably every Sunday, suppose you are watching a like a crime movies every Sunday, then definitely on Sundays you will be given a recommendation of uh, like there are some recommendation engines and recommender which deploy this recommendation engines are being deployed by these channels, intelligent channels, okay, which are so intelligent that based on even on Sunday, for example, in the evening, probably you will be given a romantic movie recommendation. In the morning, it will be recommending you some family movies, or in the afternoon some crime movies. So based on the time and like based on the days and month, probably you will be given the recommendation will take place. Okay, so if you just imagine here how intelligent the recommendation engine is, right? Similarly, in the news domain, if you see, every day you can see, find out that if you just enter into uh, any news channel or newspapers, basically, okay, into the website, you can just see that certain set of uh, like news are being recommended for you, and sometimes you customize it, right? I want only news from Andhra Pradesh, and that too sports news only, or maybe like about fashion news, about technology news, you want only that type of news only will be given to you. Or suppose you wanted to know about the Ukraine Russia, okay, war news only war news related to war news you want, or some international news only you are or some financial news. So you will be recommended only with such type of news only. You would have already opted it, right? In your Google you can see it, like whenever you open a new tab in your mobile, a set of news is being recommended to you, right? Yeah, how do you think that those news are recommended to you? It completely depends upon your profile. Probably it is taking data from your profile, or and you have already gave the information about your which type of movies customization you have done it, so that due to that one you are getting that particular news only, right? Similarly, in the music domain, if you see Ghana.com or as such, many channels are there. Okay, Geo Music and all, it recommends you again same like the movie, based on the genre or based on the type of music, who is the singer, and again it may come again with respect to the timings, and also with respect to, so of course many intelligent engines only they recommend the timings also, times also they take into consideration, but to a greater extent a normal way they recommend it is a simple recommendation engine simply recommends based on the similarity function, either with the items, okay, with respect to the music or with respect to the users, okay, they simply recommend you. So this is what, right? In the different domains, so you from the database to the user, uh, it recommends us what type of music, right? Set of music. So this is the way how a some examples of a recommender systems. Now if you see here, what is the recommender system? So to study this one, to learn this one, or to get the basic information, let us see about what information do we use to make these recommendations. So particularly from this database, or we store in the database, what do we need to store in the database? So what type of informations should be stored in this database, and in which structure probably, and what are the records, or what are the attributes, everything, how it need to be stored, and which format, and like how to implement the recommender system. This is our second challenge, okay, is how to implement this particular block, or how a algorithm, how to what type of algorithm should we use it for this recommender system. And third one is how to evaluate the recommender systems. Okay, how to evaluate these recommender systems. These, so our this lecture basically goes on with only these three things: which information do we use for the recommendations, how to implement a recommender system, and how to evaluate a recommender system. As I told you, this would be a very good, very basic lecture only. So which information do we use to make the recommendations? Let us see first. So if you see the sources of information in this slide, plenty of knowledge can be acquired if you just see this one in this database. Okay, what things can be stored at the initial stage? You just remember that the items, various items can be stored, right? And then some users can be stored. users, and then items can be stored in the database. If you see about these items, many so much contents about this, like the items can be stored here. You take into consideration, probably if the items are movies, okay, consider it as a what type of genre it is, and who has directed, and how many, what is the running time, how many hours or how many minutes is that particular movie, and what is the plot of that one. So some content, okay, which also describes about some a little bit about that movie, okay. So like this, different types of movies data are being stored here. The content about this particular movie is stored, right? Similarly, if you take a user, you have like some information about this user, probably call it as a demographic information, okay. You have got the demographic information. So here, this is the content based information for this one. This is content based information about each particular item. Then you have a demographic information about each user, stating about the gender, like age, profession, area, place, or whatever, maybe whatever is stored about this user, okay. What type of, maybe like if you do again go more, like what genre he likes, how he, yeah, what are the timings that he is reserved for doing some activity. So everything is stored about this particular user. The complete profile is, that is what we call it about the demographic information. Now if you see this user particularly, he may see a movie, okay, this particular movie, and then based on his likeness or unlikeness, he may give some sort of feedback to this particular movie, right? Maybe like the rating that he gave is 2 stars. Out of 5 stars, he gave 2 stars. Probably if he would have watched some other movie or watched some other movie which he likes the most, probably he would have given a 5 star. Now, similarly, suppose this a candidate is there. He must have just seen the movie, okay. He must have just seen the movie. Now this type of feedback providing, okay, the users provide with respect to each item, different items that the users get associated with, that we call it as a feedback. And this can be explicit feedback or implicit feedback. Explicit feedback means you see the movie and give a rating also for that one. You stay in a hotel and then you give a rating for that hotel. Implicit, what we mean to say is that you just see the movie. Seeing the movie itself sees that you are interested, that's why you saw, or you liked it, that's why you have seen that movie, okay. This is the content or types of feedbacks that we can provide for these items by these users. Now you take, there are also some type of information, probably this user and this user are friends, okay, they are friends. So this type of information if we are having, or they are in a group, they are in a community. So if you go to Facebook, you say that Facebook, in Facebook probably that you are NIT Warangal community, IIT DM Karnool community. So which mean to say that suppose a link is opened and a cluster is formed there for all the candidates belonging to that particular community, right? And they are probably, they know each other, they are the friends, or they belong to a particular domain. Or maybe like you like some movie, okay, or like a actor, okay, you like an actor, probably if you take Amitabh Bachchan fans, okay, club, okay, fans community, it means that there is some likeness. If you see, if two of us are in a community, it means that there is some sort of similarity between you and me, right? This is what the social information that we feed up, okay. This is the social information that we feed up. Probably we are friends, or we are associated, some sort of similarity is there between you and me. So this is user 1 and user 2, okay. So this type of information, so these are different types of sources of information that we attain from these items and users. Okay, please remember this one: content based information, the feedback, the demographic information, social information. Probably many other types of information may be there which may come and fit into one of these four types. Now, this this as we said initially, is that like this is the feedback information. It can be explicit feedback or it can be an implicit feedback, which we say that you like this movie. Okay, and uh, so the tables that are associated, or what are the things that are associated with this explicit feedback and implicit feedback, or a feedback basically, is the ratings, right? User one, some item one, rating how much he has given. User one, item two, how much rating he has given. And it is not mandatory that all information probably you will get it. And if you take that one, it would be a sparse matrix, but it doesn't bother us. Okay, it doesn't bother us. We need to understand only one thing, that there is a user, there is an item, and the user has given some rating for this particular item. And still, furthermore, to add, we may have a consumption matrix or a table which says about you have a user, and for that particular item, how many times this user sees this particular item or movie or purchases this particular item. Okay, or whatever may be the connection, we provide it with respect to the number of times. Okay, if you go to, probably we may also in this feedback we may also have some other information, contextual information basically. Okay, the feedback, contextual feedback types, little bit of contextual feedback, like you say this, like about the time. Okay, and the weather. So all these are different types of contextual information, depending upon the context, or based on the time or based on the situation, right? We the feedback may be provided with respect to that particular situation also. Okay, uh, so this additional information in this type of information is used in context aware recommender systems. Okay, mostly in context aware recommender systems, this type of information is being deployed. Now, the content based information, if you see about the content based information, so I said you that these are the items and some content about these particular items. Now if you see what tables are associated with this one, the table is about content about each item, right? What is the content about that particular item? You have the item, and you have the genre, director, probably who is the actor, the running time. Okay, how many actors are there, how many, any awards. So all the information about this particular item are being kept it here, and belong to which type of property, segregation, clustering, everything, or which type of cluster or which type of community. So based on this everything, you are going to store the complete content about this particular item. Okay, this is the context information or context based information that is being stored in the database. The other one is the demographic information. Okay, the demographic information you are storing about the users, as I said you about different types, like the gender, age, profession, the place, and many other information which are available with the user or which can be associated with the users are being stored. This is demographic information. And uh, the type of table that we use it here is basically the user id, the age, and whatever may be the, probably whatever the attributes are possible associated with the user, the height, weight, and probably anything that you wish like. Okay, that basically, see, how do we get all this information and all? How do we get information? For example, a movie is being kept it, or you must have been accessing various items in Amazon. The items, when you are entering the item itself, you need to describe about the item, you need to give all the information about the item, the content about the item, what is the length, breadth. Suppose you are uploading a table there. Okay, you are uploading a table, you wanted to sell a table. So regarding that item, the table, you need to give the complete information about the table, right? Or you are uploading a chair for sale in OLX, you have to give some description about that one, right? Maybe like this much price I will be selling it, and this is the length and breadth, how many what is the age of that particular item, probably like 1 year back you have purchased or 2 months back you have purchased, and whether guarantee information is available with that particular warranty is there for, still there for that one, or any damage that is caused. So these all this type of information that you are going to give it, right? Similarly, users and all, how do we do it? We register our details, right? When we enter into a Amazon site, generally we do have our registration with Amazon, and we have some content being gathered. In addition to that one, we try to, in the process of traversing or browsing through the different pages of Amazon, or probably like, or clicking different links, you also provide further information to them, right? To the so this is how different types of data is also being gathered, okay, about the user. So this is demographic information that you are going to give it, and some social information. Okay, you try to give some social information also, probably like the user ID, then like the user ID one is associated, has have a friendship with user ID 2, some tagging informations between user ID, user ID 2, user ID 3, user ID 4, like that. Okay, so different users. Okay, some tagging information or some friendship information, or that's why probably your not only friendship information, it's not quite that always you need to have a friendship information. See, when you're submitting an article into a journal, okay, when you are submitting an article into journal, see, in the journal, basically many of us, what we do, we register, okay, the areas. Sometimes when in the process of registration, we provide also the areas of research that we do. So that's why when a new article comes into journal, probably, see, what they do is that for an open journal with blind review, what they do is simply they pass on, they select a few users who are whom they have not assigned earlier, and then they simply pass it the content, the journal, to them based on their research interests. Okay, based on research interest and some credit scores they earned earlier. So based on that one, they pass it, and then they get it reviewed, and then they get back to you, right? And similarly, so that is assume that that is a friendship information that is being kept. But in the process of submitting an article into a journal, sometimes you tell that uh, whom, like, you wanted to give some names or maybe email IDs or some data about some users whom your article should not go with him. Okay, probably like a conflict of interest. Maybe like, see, if the see, you may be friends, but your article should not go to him, because probably they are from your own same department or same institute. So that's why, even see, sometimes, like, even for a your contender also, you do not want your article to get it processed from him. So probably all this information, everything, not only the friendship but any social information that is required, we can provide it there. Okay, this different information that can be provided here into this table. Now, so the various types of information that is available in the database are, these are the content based information, the feedbacks, and demographic information and social information. And if you take all these different types of information, you just understand that here different types of tables are associated, tables are there, right? This all this information is stored in the database. These are our sources of information. Okay, now, uh, if you take different types of information, okay, if you take different types of information, you may have the collaborative filtering based recommender systems, or content based recommender systems. So you need to understand here what is this collaborative filtering based. See, collaborative filtering means you are trying to do it, okay, which mimics from user to user, or some similarity between user to user combined together. Content based is based, it is like makes recommendations based on the preferences of the product. Okay, users preference on the product. Okay, so users preference on the product means it is linking with the product features basically. Okay, content based. So anyway, we'll go through how it is being done here. So These collaborative filtering based recommender systems or content based recommender systems, both of them, they use this database. It means to say that different types of tables. So what a content based recommender system use, which tables are used by this content based, which tables are used by these collaborative filtering based recommender systems, we'll see. Okay, we'll go through now. Now if you take a collaborative filtering based recommender systems, okay, you in the collaborative filtering based recommender systems, you use the rating table and the consumption table. Okay, you use the rating table and the consumption table mostly. Okay, you see here about this user id, item, and ratings. Also, as we told you earlier also, probably further more information may be there. And consumption table, the user id, item, and how many times he has watched that movie, or how many times he has purchased that particular item, or how many times he has liked that particular event. Okay, that type of information. Now see, if you see it, a table, probably how it can occur, or what are the contents it can be there. Like in a collaborative filtering based, if you see it here, uh, you may probably, you have you have the items, you have the users, and now this table. So what this table basically, if you see it here, what this table probably contains, the users, items, and the ratings. So this is the users, this is the items, and ratings. So if you see this one, this particular dot here, okay, so this is corresponding to user u2. So the user U2 has not rated the item I10, this particular item. He has not rated. Some value if you take it, this one, okay, this particular thing. The user U6, this is the U6, right? U6 has rated the item I7. This is the I7 with a rating 4 star. Okay, it means that 4 star. Similarly, here also, if you take it, the item I1 is rated by user U1 with 5 star. Okay, this is how this is the data that is basically fed into this ratings table. Now let's take a collaborative filtering based approach. Okay, uh, now assume that you have this table. Okay, and the user u2 has not rated this particular item. Similarly, see, what are the other ways? See, this is with respect to rating, but here probably you can give it with respect to some other, okay, either with plus or minus or zero or some other values and all. Okay, just binary values sometimes you may give it. So this one, it identifies -1 means user u2 did not like, this is the u2 did not like the item I7. This one which indicates 0, the user u2 has not rated an item I10. And this one is says that here, suppose +1 indicates user u6 likes the item I6. Okay, this is now uh, so this is again with respect to the number of times. Earlier with respect to the ratings, or with respect to plus or minus or neutral, you can give it. Or here with respect to the number of times, as the number of times. Here what did we do it with respect to the rating? Here plus or minus. Earlier we said with respect to the ratings. Okay, completely 5 star, 4 star, 3 star in a scale. Okay, here we do not use a scale, and here we use the number of times. Okay, so if you see here, this 15, it indicates that user u6 has listened to this particular item, music or probably movie, has watched this movie 15 times. Okay, so user u6 has listened to the item I7 15 times. And here nothing, 0, it means that the user u2 has not listened the item I10 at all. Now, in a collaborative filtering based recommender systems, you use this users, items, rating, and then the consumption also. Okay, user item, sorry, user ID, item ID, and the number of times. So for a content-based recommender system, you're trying to use about the contents, right? About the contents, right? For the collaborative filtering system, you can see that you use two tables. These two tables are mostly used: ratings table and consumption table. Okay, user ID, items, and then ratings or consumption. Along with that one, probably number of times also you can give it that one. If rating is not there, probably depending upon the consumption type, so you can give the number of times also. Here in the content based recommender system, you see here you have the items table, the content of the item, the consumption table, user, item, and how many times. Okay, and you have got the user's profile also. So based on the contents of the item or user, along with the consumptions. Okay, combination of that one, probably you can put this one. If it is there with a number of multiple times, how many times it is used to enforce or reinforce your status of likeness for that particular item by the particular user, you can use it this one. If it is not available, fine, but it is items table and users table with the content of the items and users. Now if you take this, like assume that we are having the collaborative filtering based recommender system and the content based recommender system. Okay, you are having a collaborative filtering based recommender system and a content based recommender system. So both of them, what they do, from the database only, whatever is there available, they recommend using some recommendation and algorithm, and then they recommend it. Okay, for a new user, they do recommend it. Now here, only the thing is that this collaborative filtering recommender system or this content based recommender system, how the recommender system engine works, or what further filtering that you do it for the database and then you have it. This is the difference here, both. Okay, for both of this one. Now you take it a cold start problem. Cold start problem means when a new user comes or when a new item is entered. Okay, both of them. Okay, when a new user comes or when a new item comes, that is what is cold start problem, generally we call that. Okay, in recommender systems. So when a new item or user enters the database, what should be recommended to him? Similarly here also for the content based recommender system. Now for the cold start problem, considering a new user. Okay, for a new user, so a new user comes here with a user ID, and this so when he is to be entered into the database. Okay, user ID, item ID, and rating. Probably the item ID, probably it may be 0 for him. Then what should be, because it is 0, probably other things also may be 0, or he may also have it have few things which may be entered and which may be which may be given here. But for a new user, probably you do not have these particular items. Okay, you do not have items and the rating, corresponding ratings. Then in that case, how do we rate? How do we recommend that particular user? So you have here, you from this database you are having. So you are having the user ID U12, for example, 11 users are there, and then a new user comes here, U12. Okay, which is, he doesn't have any item earlier purchased or being recommended, or he has not been associated with any of these particular items, I1 to I15 like this. When a new user comes here, now what should be done? What should be recommended for him? Okay, what should be recommended from him? If you use a collaborative filtering based mechanism, how you should do it? If you use a content based method, content based recommender system, how you should use it? If you use this one, see, users, this collaborative filtering system based recommender system, basically it uses similarity between user and user. Now you see this user, he doesn't have, what is the similarity between u2 and u12 and u11, u11? Okay, U12 and U11, U11, user 11 and user 12. What is the similarity? There is no similarity at all. Similarly, user 10 and user 12, no similarity. So if you take all these users, there is no similarity between this particular user and this particular user. So in collaborative filtering based recommender system, a new user, or especially the scenario of cold start problem, cannot be recommended. Okay, it cannot be recommended. Now let us take a content based uh, recommender system. Now suppose a new user comes here. Okay, a new user is there, and assume that you are giving the genre he likes in the process of registration, because you are trying to, now you are trying to take the information. See, earlier if you see here, you do not have, he has not purchased any item probably. Okay, he has not taken it, but here when you are registering, you are trying to provide the some content, right? Probably the genre or any other content and all the content you are providing. So matching with this particular, so user ID, this one, suppose uh, item item ID is this one, Godfather, and if it is crime, then you can, the director is this one. So probably, so this one new user is a crime type. Okay, he likes the genre crime type. So you can recommend this particular movie, Godfather, to this particular new user. Okay, so this is a, in content based recommender system, this is possible. For a cold start problem, it is possible, but for a collaborative filtering based recommender system, it is not possible to recommend anything for a new user, especially the, new user in the sense, in the scenario of a cold start problem. Okay, so here collaborative filtering based recommender system suffers from new user cold start problem. Okay, new user cold start problem. Now, if it is a new item, okay, if it is a new item, can we recommend that one? Can we recommend, like, to which user we can recommend? Can we do that one? Now, similarly, the same as that we have seen it earlier for the collaborative system and content based system, we can just check it here also. Okay, so collaborative filtering based recommender system, if you see in the database, we are having again this user ID, item, and rating, and that if we escalate it for a table, okay, for the complete details you have here. Now, item 1, you see here item 1, item 2, item 3, item 4, like that, item I16. Okay, I16. Now, using a collaborative filtering based recommender system, there is no sort of similarity between any user being purchased earlier this particular item. So no recommendation is possible even for this particular item. This new item is not recommended to any user, right? Whereas you take it a content based recommender system. Okay, you let us take a content based recommender system. So when an item is given, okay, when an item is given, the item number or something, you are going to give the item ID, then what type of genre it is, what director, like this it is. So you are giving here genre, for example, crime type of things. So here, whoever the user likes crime type of movies, he can be recommended this particular item. Now, that's why initially when you feed the movies or music types or any other items, okay, it should be, so you have to be very properly putting that particular terminologies which is associating. And similarly, this is the same thing that you are giving when you are submitting an article into a journal. They ask us our feedback, keywords, right? Why do we give that keywords? Basically because it has to match. Suppose somebody gives a search, somebody is working in this and they recommend, basically, right, in your Google Scholar, or probably in a new article is recommended to you. If you registered in Google Scholar, and then probably like you give, select some areas, data mining, recommender system, artificial intelligence, some type of things, that areas that you register with. Okay, what are your liked areas and all, or which is your expertise areas, or which the areas that you work with in your research. So when a new article comes in that particular domain, automatically that article, when Google pulls, okay, when it is appearing into some journal or some conference proceedings or some book, okay, or when it is floated into the website, automatically that article is being recommended to you. It is recommended only because the main reason is that you it is recommended to you because it is the type of keyword that you have used, that was used particularly in that particular article, which relates with your research area. Okay, this is how. Or see, suppose you are using a Netflix, or probably you are using Hotstar. Okay, what happens? Disney Hotstar or Netflix or Amazon Prime and all, when you are going, see, a number of new movies are being released every day throughout the globe. But why only Telugu movies are recommended to you, or why only Hindi movies are recommended to you? Probably you could have, they are also different types of genre, or probably it may be a same type of genre. Maybe a romantic movie is released in Japan, in Singapore, and in US, Europe, in South Africa, in India, and in India again, probably like in Andhra Pradesh, one movie is released in Tamil Nadu. So, but native to your language, native to your particular uh, seeing of that particular movies in a particular language, okay, your likeness, it is going to recommend to you, right? This is the same way this content based recommendation system, it works here. The content based recommendation system is working here. Okay, the content based system, recommender system is working here, because when you enter a new item, you give some, describe something about that one, the content, you are feeding some content about this particular item. Due to that one, see, each user writes different types of genres, and a user which write which is liked by the genre which the movie belongs to, or the movie's content belongs to, definitely that particular item will be assigned for this particular user. This is what a content based recommendation works, even for a new item. Okay, even for a new item. So here you see, uh, even for a cold start problem, okay, if it is a new item, it suffers, this collaborative filtering based recommender system suffers from the cold start problem. Okay, new item cold start problem, this is what uh, so for a cold start problem, basically, whether it is a user based, whether it is a user, new user, or a new item, the collaborative filtering system based recommender system, okay, fails. It cannot, it suffers from cold start problem. Okay, but whereas content based recommender system is active on that one, and it can recommend. Okay, it can give recommendations. Now, so but you need to understand one thing. Let us understand about, earlier was a cold start problem. Okay, now it is an obvious recommendation. Obvious recommendation means it is like a conventional. Okay, this is done by this collaborative filtering system, filtering, collaborative filtering based recommender system. They do not recommend obvious items to the users, but content based recommendation system, they do it. So it is obvious recommendation to users. So this is one of the drawback again. It should not be. Okay, so for an obvious recommendation system, if you see, uh, or you see that, like okay, on a whole combined together, for a collaborative filter, the differences, if you see, the collaborative filtering based recommender system and the content based recommender system, this collaborative filtering based recommender system suffers from cold start problem, but they can provide interesting recommendations. Okay, they can provide interesting recommendations, whereas this content based recommender system, they avoid this cold start problem. Basically, for them there is nothing called new or old. When content is there, simply they recommend it. Okay, this is what is done by this content based recommender system. But they have problem with this obvious recommendation, because whatever recommendation is being done, they are obvious, and majority of the recommender systems today use these content based recommendation systems only. So what we need to have, we need to have some hybridization where we can work with this cold start problems also, and then we can work with this obvious recommendation also. Okay, so we should be having some hybridization of this one. So how we can do it? So now the thing is, so we worked on which information do we use to make the recommendations. Now the next thing that we should will deal is like how to evaluate a recommendation system basically. Okay, we'll see this one, then we'll try to see about how to implement a recommender system. Now, in the process of evaluation of a recommendation system, various parameters need to be taken into consideration. Okay, the first one is accuracy, diversity, the trust, the serendipity. Now, accuracy, see, suppose you recommend, okay, if a recommender system does recommendation, okay, if a recommendation system does some recommendation to a user, recommends an item to a user, okay, if a recommender system or a recommendation engine recommends an item to a user, do I like what the recommender system likes it or likes me, or do I like what the recommender system has given me to watch that movie? What is the accuracy? See, out of 10 times, how many times it has given you positive results, or how many times it has given you negative results? So this is like, what is the accuracy of that particular recommendation system? So definitely we need to, while designing a recommender system, we need to take some data set earlier probably, and then we need to train it and test it, and then give a accuracy level which is considerably okay, good level of acceptance by the users or the community, and then only we need to float it that as a recommendation system, right? As a to the recommender engine. Otherwise, we cannot give it whatever we like it. Okay, even if it is the accurate acceptance rate is 30% accuracy, we cannot give it like that. Okay, we cannot give it. We should not give it like that. Probably you may lose the users also. So this is about accuracy. Okay, so designing an algorithm, it should be, the recommendation should be high. The accuracy of that recommendation should be very high. Then only probably I always like it. Okay, so whatever is recommended, I will. It is simply like, suppose you ask a doubt to your your child ask a doubt to you, uh, always, okay, a small doubt, and sometimes you tell good, and sometimes means right answer, sometimes you tell wrong answer. Suppose your son asks a doubt, son or child, okay, asks some doubt to you for clarification about different who is the president of India, who is the president of America, who is the president of, so out of 10 times, suppose you are telling 8 times wrong, do you think your son will believe next time to you, or your child will believe you? No. But if it is high set of this one, like accuracy, it means to say that suppose out of 9 times, out of 10 times, 9 times you told correct. Okay, whatever your son asks or a child asks the doubt, you have answered him right. So you are even, see, children are so focused that out of 10 they expect 10 times also right for you. Even once when you tell no also, they are not going to accept it. They tell that my father doesn't know or my mother doesn't know. Huh? So this is what this is what about this accuracy of the recommendation system also. I'm just wanted to, it's an analogy that I wanted to focus it here. The same way, if a recommendation system is recommending you, always recommending you greaterly, you will trust that recommendation engine, right? You trust that one, and you try to believe, like suppose you wanted to, next time you wanted to go and purchase something, this and these are the features that I want, or these are the things that you tell, and it recommends you, or you simply you tell that I need a phone to be purchased, okay, and it recommends you the best phone that you desire it. Every time it recommends you, it recommends you good, definitely you will trust that engine. So this is what about accuracy, right? The number of times it gives you always true results, which means that to your likeliness. That is what we call it about accuracy. So another thing is that not only always giving me results about the mobile phone only. Okay, sometimes it has to give me different types of recommendations. See, sometimes, see, it is not like only I like romantic movies, so I should get always romantic movies only recommended to me. No, probably depending upon my usage or like that of this Netflix, it should recommend me sometimes some diverse type of movies also it should recommend me. So diversity says about, does the recommender system offer me different kind of items, not only a single item but multiple so many varieties of items, does it recommend me? This is all about the diversity. Okay, now if you take about the trust and reliability, or the reliability and explaining the recommendation systems, so has the recommendation system the ability to convince me about their recommendations? So can I rely on that? See, suppose you just go and type it in Google. Okay, simply you type it in Google, and then some website you enter into some website, and then mobile phones you enter into some website, and then best phone for me. For example, you just type it, and it recommends you some phones. Like how much you are reliable with that particular site. So it comes also the recommendation engine. So it also like you need to understand one thing, that how much that recommendation system is reliable to you. Can you rely on those particular recommendation systems? Probably you are purchasing a phone which is worth 1,50,000 or 2 lakh rupee phone you are purchasing. Are a one time measure, you are trying to do it for next 5 years, I will not purchase any phone. Or probably your son wants something, a item or something which is very rare and it is available in foreign. Okay, you want a electric scooter, your son wants a electric scooter, you are purchasing an electric scooter of worth 80,000. So when you are spending that one, you should be reliable about that particular recommendation which recommends you. So if that particular site recommends you, and then you purchase, and then it is not up to you your use. Okay, yet the content, or the configuration that is given is not up to the mark, then what you will do? You will not rely next time on the recommendation system. And why it is giving you, probably suppose if something is recommending you, okay, some item is being recommended to you, you should also take into consideration, or you should also be explained, like why this particular, because that's why sometimes in Netflix or maybe like in Amazon Prime, if you see, because you watched movies recommended because you have watched this movie, right? Suppose you watch a thriller movie, okay, a thriller movie, you watch it, and then afterwards after completing of that movie, if you just go down, you will see that it recommends you based on different things. So probably it will give you like new releases, recommend based on the language, recommendation based on your genre, okay, recommendation based on because you watched that movie. So that is explaining their recommendations, whether. So this is how the trustworthiness you try to attain with that particular recommender systems. And the next one is about serendipity. Serendipity says about how much novelty that particular recommendation system can give you. So as earlier we have seen about different two types of recommender systems, like collaborative filtering based recommender systems and content based recommender systems. The content based recommender systems never gives you some surprise, simply based on the content it is going to give you, but some novelty also you may require it. So such type of things probably you may get it from collaborative filtering based recommender systems. So it should also, okay, what is the serendipity score, or what is the novelty? So are like how surprising are the recommendations to you? See, if something is recommended to you, definitely you like it, that one, and then probably like you must have not known that, maybe like based on some feature of you, probably assume that probably you were searching for some type of gift item for your better half just one day before her birthday, and you could not purchase that particular thing, and in the next year it recommends you similar type of gift which is of higher like higher quality or better quality. It can surprise you really. That is what about the noveltiness of explaining you, maybe like based on some feature which you like it, or some hidden feature which you must have not provided to the system, but it has trapped you, or got it has got the information from you based on your clicks, or based on your activities that you do with the internet. Somehow it has got the information, and suppose it gives you some surprise. Okay, so this is how different parameters that we need to take into consideration for evaluating a recommender system. Now let us see how to implement a recommender system. Okay, now the basic architecture is like this. You have the database, okay, and some matching function, or you have a matching score function or matching function basically. Okay, now what do we do for each item? So the user, for each user, for this user for example, probably you provide some filtering, this one also probably in the next slides, few slides we are going to get it, that one. So from the database you take each item, you filter it based on this filtering mechanism. Probably you wanted only electronic items, or maybe like you want flights only during this time to this time only you wanted to travel for the flights, selected flights, early morning flights you wanted to catch up, maybe like provide some filtering we give it, right? Or cost which is only less than 1000 rupees only. Gift items you type it in Amazon, or probably in Flipkart, gift items, and you give only the filtering that you give it, like the upper scale for that one is that the cost is, it should not exceed more than 1000 rupees. That is what is the different types of filtering. Okay, so each of this movie, then it computes a, for this, suppose this particular item, suppose a movie here, okay, for example a movie here or an item, this item is having a matching function with this particular user, and then a matching score is produced. Okay, a matching score is produced here, 4.5 probably. Okay, assume that this is for this particular item. Okay, this is for this user, the score is 4.5. Similarly, for other items, okay, different types of items, the scores are computed here. Now you have got again more items. Okay, more items are given, and then the scores are computed. Now if you take it that way, okay, let us take this one. For different items, different scores are computed, and then it continues on like that. Now how do you take this one out of this one? So out of this one you try to get it, okay, the best score, probably 4.7 is the best score, you are going to get it. Now as I said you, sometimes there is a possibility that in this filtering itself, you do the filtering, provide additional constraints depending on your domain. Okay, maybe like a geographic recommendation system. Suppose it is the geographic recommendations also are given here. So, or like depending upon the geography, or depending upon the, as I said, you the cost should be this much, and only the vendor should be available within your city limits only. Okay, or like I want only from India only. Okay, I want all the Telugu movies, only Telugu movies to watch, for example. Okay, so if I give it based on language, okay, or based on geography, or depending upon any particular domain. Okay, here Either you can use it here or here. Select items with the highest score now, and then it recommends to you. Okay, it recommends first this one is recommended probably, then next this, then next this, like that. Okay, so again based on this particular thing you give a ranking. Okay, there is a ranking, of course. That ranking system, that one is can be taken from the information retrieval strategies, different strategies that one can be used for ranking of these particular items again. Okay, these are the recommendations made for this particular user. Now uh, so you say this one, this, if you take this architecture completely, this complete thing combined together, including this filtering and this filtering and this matching function combined together, only you call this one as a recommender system. This is an architecture of recommender system. Okay, now here you should know a little bit about this matching function. Matching function is like, it uses, or the idea behind this matching function is the most relevant process, or what you can call this one as the similarity, how much similarity for this particular item for this particular user, or how much he likes this one. The similarity means earlier probably he used that particular that type of movies, that genre of movies. So when a new movie of genre comes, that particular genre comes, probably the matching score or the similarity score from earlier to current will be more, very high. So that is the most relevant process has to be taken into consideration here. Okay, or the most similar value has to be taken into consideration with respect to the earlier what this particular this user has opted for. Now then, so based on this matching function, okay, based on this matching function and what type of filtering you are using it here, okay, filtered data that you are using it here, you are having two types of recommender systems again, based on memory or based on models. Okay, based on memory, an example of this one is KNN algorithm, K nearest neighborhood algorithm. And based on models, you use some, probably like some of them are like the matrix factorization algorithms. Okay, a matrix factorization algorithms which is based on model, and KNN algorithm which is based on memory. So here, based on this matching function, you use either the recommender systems which is based on memory or based on models. Now, so if you see here, based on memory, you use this filtering and then matching, and based on recommender system, based on models. If you take it based on models, you need to understand one thing, that this database model has to be derived or maybe like attained from some other database. Okay, or this database, or you have an intermediate database between this database and this filtering. That is what we call is that the model need to be learned first. Okay, the database use a learning algorithm, and then, or like a learner algorithm is, or the modeled data, this direct data you cannot use it here. Okay, for a model this based on models, so this data comprises completely based on some learning models. Okay, and then that one is that we get to filter it, and then we use this matching algorithm. Okay, we use this matching algorithm. So this is based on models. Okay, if you based on models, then you have the database and the learner concept. Okay, the model is being learned, and then a model is designed here, and this database, it goes through that model, and that data only which you get is the modeled data or modeled database. Okay, you use it. So a recommendation system, for a model based recommendation system is this. Additionally, you can see that this database also is there, or learner, then you have the model data which can be filtered, and then you have the matching function and the other filtering function. So in a model based recommendation system, one learning activity is also added here. Okay. Now, so few things about this one is that, like, uh, for a recommender system which is based on, either it can be collaborative filtering or it can be content based. Okay. uh, you can say that based on memory, if you take a if you like these particular obvious recommendations are provided, whether these particular things are non-scalable. Okay. The algorithms are non-scalable, they are or whether they are scalable. Okay. So for a model based recommender system, model based recommendation system, the scalability is there. But for a memory based algorithm recommendation system, scalability is not permitted. And but one more thing, for a memory based, it is easy to understand and justify the recommendations, because they are basically an obvious recommendations. Okay, it is easy. But for a model based, because in a model based, various types of computations are being taking place there. Okay, different little bit heavy computations, probably as a minor, as I told you earlier, like a matrix factorization, or as such some types of things which are little bit, the computation levels are hard to understand and justify the recommendations. Now let us see for this, like a recommender system. When you take it, if you take a collaborative, so you have a database, you use this database, how, what type of database, it is a data or like a modeled data, or like it is a raw data. Okay. So if you use a collaborative filtering based recommender system, or if you use a content based recommender system with memory based or model based, what are the examples or how it works with? Okay, if you see here, some of the algorithms that are used, okay, uh, are like, for a collaborative filtering based recommender system with model based, some methods that are used are like Pearson correlation and singular value decomposition, or probably like sorry, the singular value decomposition, you can use it here in content based with model based. Then some other, any correlations, okay, any correlations are used here. And similarly here, different types of factorizations you use it, matrix factorizations, like probably the classical matrix factorization, Poisson or binomial, whatever the types of matrix factorizations you use it, you can use it here. uh, some examples, okay, these are just some examples. Collaborative filtering and model based is this, and content based and memory based is, you use it TF-IDF. You can use it like a term frequency inverse document frequency. Then cosine similarity based techniques, you can use it, or latent semantic indexing for a model based and this content based. Then latent derelict allocation, okay, you can use it. Like it's different types of, these are the different types, different algorithms. Okay, probably there the list may be more, but some examples of this one. Okay, if you use a collaborating method, okay, collaborative filtering method, memory based recommender system, content based, memory based recommender system, then what are the examples of that one? Okay. uh, like, you let us see a few things here. Okay, suppose we are using this collaboration filtering based and memory based. Okay, now you see here an example. Okay, what it should recommend. If you see, for example, what should be recommended for U3, a user U3, what should be recommended? Okay, here for this particular thing, whether this item I3, for user U3, whether item I3 should be recommended or not. Okay, it should be recommended or not. Yes, because we are trying to use it, the collaborative filtering based and memory based. So here if you see it, the system predicts that the user U3 will like the item I3. So if there is possibility only, then only you can recommend, but there should be some background behind that one. The reason here is that, see, the other users, if you see U1 and U2 here, U1 U2 with similar taste of U3 likes the item I3. You see this one, 5 star rating user U1 has given, U2 has given some ratings here, and user U3, if you see this both, it is matching. This it is matching. You take it with U1 or U2, it is matching, or there is a high level of similarity between this user and this user. Okay, this user and this user. So that's why, see, if you take it collaborative filtering means it should be user based, right? It is user based. So user and user. So some compute the similarity between the user U2 and U3, U2 and U3. Okay, U1 and U3. So can you compare? So if you compare, there you can find out a lot of similarity between these users, right? So that's why user U1 and U2 like the item I3. That's why you recommend item I3 to this user. Okay, this particular user. This is what a an example of collaborative filtering memory based algorithm works. Now let us take the collaborative filtering based and model based. Okay, model based. If you take it, so as I told you, this collaborative filtering based, if you take a model based, it means that you have a database learner and this model. Okay, you have a data model which is learned. Okay, the data attained from the learned model, learned algorithm, and from here you get it filter, and then you have the matching function. So now you have got two tables. This so you should compute ratings. You have the table ratings and the user table here, and you try to do some factorization. Okay, some factorization between this ratings and this users, or these user IDs and these user IDs. Okay, with respect to this table and this table. So you do some factorization activities, and then now you got in this particular model based, there are different features like that for this one, like this. Okay, feature 1, feature 2, feature 3 for users, and then for ratings, if you take user ID, item ID, and ratings, you are going to get it. Now, so if you take this particular table, let us see whether in this particular model, okay, collaborative filtering model based, whether how it does. So from users, for each filter, okay, for each from this particular table, okay, you take this particular thing, and then from these particular tables, okay, this particular tables, two tables, rating table and user table, you compute, okay, using this table, these particular tables. Okay, different tables. So for each one you are going to get this table, right? In this table you try to compute the scores of these particular features, feature 1, feature 2, feature 3, like that. And now as a mapping function, what you try to do is that you get a score. Okay, the matching score is attained this way from this particular, for this particular user and this particular user. Okay, item, sorry, this particular item and this particular user. You try to get the matching function, and then here the matching function, how is it computed? It is 0.95 into feature 1 into feature 1 plus feature 2 into feature 2 plus feature 3 into feature 3. So this is how you are trying to compute the similarities. Okay, you compute the similarities, and then you get a score, and like that for each item you have to do it, and the item which has the highest score, you are going to recommend it. So this is, so now you got it based on this one. You got this score, this score, this score, and based on this particular scores, you are going to recommend it. Probably how many recommendations? So top 10 recommendations, so top 5 recommendations. Okay, again, as such, among this one, when you retrieve it again, you use some retrieval strategy here for ranking also if required. Okay. Now content based. So content based and memory based recommender systems. Okay, if you use this memory based and then this content based recommender system, what is how you can do it? So for a content based, as it is said, for different items you have got this like the description or the content of this particular item, you are going to use the content. So content has got like each of this one, probably it has got the keywords and all different keywords you are going to get it. So you get this one particularly in a table, in items table, item I1, various terms. Okay, probably different terms that are appear, and then the number of times it gets appeared probably. So this is an example only. Okay, this is an example. It may use some other different parameters also. Okay, so you have the consumption table with user id and item id, sorry, the number of times. Okay, for this user id, item id, this item id with respect to the terms and the number of times it occurred from the earlier table, what we can do it. So now if you take it, okay, the complete details about this. Okay, you are having I1, I2, I3 like that, 11 items, and then based on these particular items, okay, you have got like this is the item id. Okay, item id, and these are the different terms. Okay, these are the different terms now. So this is the table that you are going to attain it. Okay, this is the table, that information that you are having it in the database now. Okay, with respect to taken from, derived from all this table and all. Now whether this item I3, okay, this particular item in this consumption, whether a user will like this item I3 or not. Okay, for user, for example, a user, you take the consumption user consumption table also, you need to, you have it here. Okay, earlier user id and item id is there. So for each, okay, each you may have it this one. Okay, for user u1, okay, for user u1, item 1, u1 item 2, u1 item 3, u1 item 4, like that. And for this particular user, suppose you are having two items here. Okay, already he is having user u item I1 and user u item I2. There are two items. Okay, and different terms associated with that one. Whether item I3 will be recommended for this particular user or not. Okay, item I3 will be recommended for this user or not. Okay, this one, this item I3. Now the system predicts that user will like the item I3. The reason behind this one, because of the content. Okay, it has already this I1 and I2, right? He has seen item I1. Okay, he has seen items I1 and I2 that deal with the same topic with the item I3. So based on this content, you take this particular content, this content, item I1 and I2, if you take it, see, everything almost it deals with these particular items. The goal, RM, FCD, or different club, or CR7 and ball. Okay, different things. Okay, it goes with it deals with these particular terms. So that's why the item I3 should be recommended. Or so this particular news, for example, the news comprises of goal, RM, FCB, CRM, ball. That is what we have seen earlier, right? So all these need can be recommended. Okay, recommended, because there is a content similarity, right, between this item and this item and this item. If you see, there is a content similarity. That's why, since these two items are already liked by user u, the third item I3 also will be liked by this user u. Okay, because of the similarity. So how you did it, the similarity of content between I1 and I2, like that. Okay, similarly with respect to I2 and I3, like that. So that's why. Now content based, model based, this is same again. So if you take a model based, means definitely you have got you have got a model here, okay, learning algorithm, this one and this one again, this database and this database, you need to do again the comparison activity, okay, or factorization activity, again you need to perform it, okay, and then some factorization, or from here you do the you derive this one, right, you derive this one, some factorization activity takes place, and then you get it again, you use this same some matching scores here, same like what we have done earlier, and then based on the, so here only the thing is that the model based, okay, in the model based what you are trying to do is that uh, earlier you did some factorization activity, but here, okay, here you need to remember that from this database you are deriving this particular database or this particular table from this one, okay. This is the difference, okay, please remember that you did factorization, here you are deriving it, okay, you are using a model now. So the model here is the matching function that you use it for this content and this content, okay, and you are trying to compute again the similarity score between the different features, and then you attain the score, and again this particular item I3 will be referred or recommended only if that particular like score is very high, okay. Now there are also hybrid mechanisms, there are also hybrid mechanisms. If you see here, okay, assume that we are having a news here, suppose an item I2 is there, the World Bank project global, again you are having the same, and the ratings this one, and then now you have this particular, you have this particular table here, you have the items table, users table associated with that particular item also. Now can we see, okay, this user u2, suppose a not new user, this one user is there, already a user is there, okay, old user only, with the ratings, some ratings for I1 and some ratings for I2, 5 rating for I2 and 4 rating for I1, it is there available, whether item I3 will be recommended for this particular user if an hybrid mechanism is used, okay, hybrid mechanism is used. How should we do it for this one, okay, how should we do it for this one? So two reasons here given, he likes item I1 and I2 that deals with the same topic of the item I3, right, earlier these two are liked by same like the content based, when we what we have seen content based, right, he likes this item I3 also, he will like it. The reason is that he already liked I4 and I5, I1 and I2, which have the same sort of similarities there between these two items. So this is one reason. The second reason is that other users, here you see user U1, he liked, okay, he liked these three, item I1, I2 and I3. So other users U1 with the same taste to U2 likes the item I3. Okay, likes the item I3. That's the reason. Okay, that is the reason. In two ways. Okay, item this user can recommend, can be recommended this item I3. Suppose another user is there, U3. Whether he can be recommended, he can be recommended item. What is this item? I1, and suppose new three items are also there, okay, I9, I10 and I11, these are new items, but the item details are given there, okay, item details are given there. Now can we recommend item I9? Similarly I1, can he be recommended? So if you see here, simply a content based recommender system cannot obtain this recommendation. The reason is that there is no similarity, okay, there is no similarity between this item I1 or with respect to this particular any users also, there is nothing. But now you take it with respect to this particular item I9. If you see here item I9, okay, you see these two 5, okay, he has given rating earlier to 7 and 8, item 7 and item I8. These two are given. Now if you see here, okay, if you see here with respect to the content here, okay, 14. So these two items, item 7 and item 8, have a great matching. Similarly, item 9 is also having a great matching with this item I7 and I8, right? So that's why what happens here is that 5 is there. This is rated. This he already liked item I5, item I7, and item I8. So since there is a mapping, great matching similarity between these contents, okay, I7, I8, and I9, I9 should be recommended to this particular user U3. Okay. So this is okay. Let me stop it here. And any questions? Let me please be going through. Any questions?
So in the last case, we would not recommend the I1 item, right?
Yes, yes, yes.
Okay.
Any other questions?
So I think you covered it all.
Okay,
So
thank you.
yeah. So thank you, sir, for such an insightful session. With this, we come to the end of the day 2 of the course. We shall meet again tomorrow at 4:30 p.m. for more such sessions on the same platform. Thank you all for joining. We will end this meeting now.
Okay, thank
Thank
you.
you, sir.
Thank you.